The following content is for entertainment and educational purposes only. It does not constitute means for diagnosis, healthcare advice, nor treatment. Make use of a qualified healthcare professional for such purposes.
Today's lab, we are going to go through what exactly multiple regression is and how to interpret those kinds of tables as well as models. First, before we understand what multiple regression is, we need to just take a step back to review correlation. So sum of squares, SS, that basically refers to the variance. What is the relationship between two variables? And when you're looking at this, we have specific terms for these variables. Our independent variable here, it's instead called the predictor variable, also referred to as X. Then our dependent variable, that is the outcome variable, and it is referred to as Y. So correlation coefficient, that is represented by R, and it basically measures the strength and direction of the relationship between those two variables. The way you can look at this is that, see this example here? The correlation coefficient, its range goes from -1 to +1. So that's its range, nothing further than that. The direction, you want to take a look first at the sign, because that is an indicator of the direction of the relationship specifically. So if we look at the plus sign here, that indicates a positive relationship where both variables, the predictor variable and the outcome variable, are going in the same direction. And then the negative sign, that refers to a negative relationship, a negative direction, where one of the variables goes in one direction while the other variable goes into the other direction.
So let me give you guys an example of a relationship, right? So think about a positive relationship. That means that they're going in the same direction, right? So for example, the more therapy sessions the person does, the more well-being scores, the higher the well-being scores are going to show, right? That will be a positive relationship. A negative relationship, on the other hand, is if one goes up, the other one goes down. One goes up, the other one goes up. So think about a negative relationship. So for example, there is a relationship between the amount, the greater the therapy sessions, the less symptoms of depression the person is going to report. So that therefore will be an example of a negative relationship. I don't want you to think about positive and negative like arithmetic, like adding or subtracting. This simply means that if they are positive, they're both going in the same direction. Whereas if the symbol is negative, it means that they are the opposite direction. Let me ask you a question. Which relationship is stronger? -1 or +1? Who says +1 is a greater relationship? Who says -1 is a greater relationship? Neither is stronger, because that range would mean a perfect relationship. So the one, think about a perfect relationship 100%, right? Whereas no relationship will fall in the middle. So we would have no relationship with a 0. But the negative and the positive doesn't necessarily mean that it's strong or weak.
So as Dr. Michelle was saying, we have the direction, but we also need to look at the strength of the variables. So just like we look specifically at the signs to decide the direction, we need to look at the actual number to decide how strong that variable is, how strong the relationship is between those variables. So you can see here that the strength, there's a series of numbers that are correlated. 0.3 or less, that's considered pretty low strength. 0.5, okay, 0.5, that's in the middle. So that would be considered a moderate strength for that relationship. And then at 0.7 or anything higher than that, that would be considered high. So now that we understand correlation, we can now apply it to multiple regression. When we're looking at correlation, basically why we're doing this is to explain the effect of the predictor variable on the outcome. So how much of an effect does it have? What is the variance? So the coefficient of determination is very important in extracting this. And it is represented by R squared. And this is simply the variance of the predictor explained by the outcome. So if you look at this coefficient of determination, which equals 0.4, this simply means that the predictor variable explains 40% of the variance of the outcome. So you can replace this with any number, and it would explain that percentage of variance.